General solutions to a differential equation. All right, so good day, people. Today, I want to look at the general solutions of a differential equation. The general solutions of a differential equation. But before we start with it, there's one thing I want you to understand. Previous videos, you studied the order of a differential equation. And we said the order of a differential equation is the highest derivative, where we gave an equation of like this: exponent half plus y is equal to r squared cos of omega what t. And we said the order of this differential equation was 2 because that was the highest derivative in the differential equation. Now what happens is that if you have a differential equation, want to know the order of the differential equation, the number of arbitrary constants in the solution gives you the order of that differential equation. So now what we want to do here is that there will be a solution that will be given to you, and you'll be asked to generate the differential equation from the solution. So they will give you a solution and they will ask you to generate a differential equation from the solution. So for instance, they can give you a solution of this nature, that y is equal to negative 4x plus c. Y is equal to negative 4x plus c. So the moment you realize that you have only one arbitrary constant, it means that the order of the differential equation, when you are done solving, you should have one order of the differential equation. Okay, so now to find this differential equation, what do? You find the integral of, your dy of what? Your dx. When you find dy dx, you get what? Negative 4 plus what? When you differentiate the c, you get, it's a constant, you get 0. So therefore, your final differential equation will be dy dx, which is equal to what? Your negative 4. So now, what happens here is that because the arbitrary constant in the question was only 1, after the differential equation, you got what? Only one order. So if the arbitrary constants are 2, after the differential equation, you must get 2 orders. For instance, if I put here c1x plus another c2, then after my differential equation, I should know that I should get 2 orders. So I have to eliminate the 2, find a way to eliminate the 2 what? Constants. So upon doing that, I have my dy on the x, which will first give what? Negative what? 4 what? 4x plus what? My dy here, which will give negative 4 plus what? c1. And I have my 2y over the x squared, which will give what? Me 0. I get in it. So now when I get 0, I've eliminated the c1 also go to 0. So in case here was maybe an x squared, then I'll get here as what? Negative 8x. And I'll come and get here as what? Our negative 8. You get it? Why? Because I've solved the differential equation. I've been able to eliminate the arbitrary constant. So I had a second order because I had 2 arbitrary constants in the solution. All right. With this said, let's look at one particular cumbersome example and look at how we can deal with that. One particular cumbersome example and look at how we can deal with that. So now, we've been given a solution. And the solution is that y is equal to c1 e exponent negative 2x plus c2 e exponent 3x. Now, pay attention very well because I'll be giving 2 ways you can easily solve a question of this nature. So now, when you have something like this, the first thing you should consider is that you're having 2 arbitrary constants in the question. So that means you need 2 differentiation. You need 2 differentials. You need 2 order differential equation. A 2 order differential equation because we have 2 arbitrary constants. So first of all, we find our first one, which is our y prime, and which is the same as dy on the x. All right. So now when you find that when you are differentiating this, you get minus 2 c1 e of negative 2x plus this 2, and differentiate this, you get 3 c2 u of what? The 3x. All right. And because it's 2 arbitrary constants, we need a second order 2, which is the same as y prime prime, and that is equal to what? This and this will give what? 4 c1 e of minus 2x plus this and this will come and give you 9 c2 e of what? 3x. All right. So now let's label them as equation 1, equation 2, and equation 3. Now, to solve them, you can either go by the substitution and elimination method, or you can go by the matrix, finding the determinant of a matrix, where we can rearrange this as a system of equations on a matrix table, and we find the determinant of that particular matrix. So now, first of all, let's look at the substitution and the elimination method. All right, we want to get away with the C2 and the C1. So how do we go about that? Now, when you consider the equation 4, equation 3, and equation 2, let's multiply equation 2 by negative 2. So equation 2, let's multiply by negative 2. When you multiply equation 2 by negative 2, what are we getting? Negative 2y prime is equal to negative 2 times 2 give you 4, C1 e negative 2x, and negative 2 times this will give you negative 6, C2e 3x. C2e 3x. And let's call this equation as what? Equation 4. Now, if this equation is our equation 4, what can we say again? When we compare equation 3 and equation 4, we can eliminate what? C1. When we compare equation 3 and equation 4, we can eliminate C1. So let's say equation 3 minus equation 4. So when you do that, we can eliminate C1. So we can have y prime prime minus 2y. This will give you 2y prime, which is equal to 4c1 this minus that. They'll go away. And you get 9 minus this, which will give what? 15c1. Sorry, 15c2 e exponent what? 3x. Alright. It's like grouping like 10. Here is C1, C1. Here is C2, C2. And let's call this equation as our equation what? 5. Alright. If this is our equation 5, when we consider equation 1 and equation 2 too, there is a way we can eliminate C2. Okay. Let's consider equation 1 and equation 2. We can also eliminate what? C1 from this equation, so that we can finally come and eliminate C2 over here. So now if we want to eliminate C1 from this equation, let's multiply equation 1 by 2. Let's multiply equation 1 by 2. So now, if we multiply equation 1 by 2, what are we getting? We have 2y, which is equal to 2c1 e of negative 2x plus 2c2 e of what? Of 3x. And let's say that equation is our equation what? Equation 6. Now, if that is so, then what we can say here is that, if that is so, then what we can say here is that comparing equation 2 and equation 6, we can eliminate the C1. So let's say equation 2 equation 2 plus equation what? 6. So when you do that, we get y prime plus what? Our 2y, and we get negative 2 this plus 2, which will give you 0. So this will go to 0, and we get equal to 3c2 this plus 2c2 this, which will give us what? 5c2 e exponent 3x. And let's say this is our equation what? 7. Now, equation 7 and equation 5, we can eliminate our c2 over there. So this is our elimination, that's substitution and our elimination. So now I have y prime prime plus 2y prime, which is equal to our 15c2 e of what? 3x. And I have y prime plus our 2y, which is equal to our 5c2 e of what? Of 3x. Our 5c2 e of what? Of 3x. Now, when this happens, we can multiply this equation, which is equation 7, by 5. So multiply equation 7 by 3. You get 3y prime plus 2y plus 6y, which is equal to 15 C2e 3 exponent 3. And now the new equation we've gotten, let's say it is equation what? 8. If it is equation 8, then what can we do over here? Comparing equation 8 and equation 5. So equation 8 and equation 5, we can simply say equation 5 minus equation what? 8. That will give us what? Y prime prime 2 minus 3y prime will give what? Minus y prime, which is equal to, I have 6 prime over here, so plus 6y, which is equal to 15c2, 15c2, which is equal to 0. So this becomes the generated differential equation from this particular solution. So now you have, it can also be written as well, dy squared over the x squared plus, minus dy over the x plus 6y, which is then equal to what? 0. Plus 6y, which is then equal to 0. Now, let's look at the matrix alternative. Now, with a matrix alternative, you have to put these three systems into a matrix table. And now when we are putting them onto a matrix table, this is what happens. Our y, which is equal to the solution, we represent it as what? Minus y. Now, this is how the solution is. Let me just write here so that you see. So the first one becomes like minus y plus c1 e minus 2x plus c2 e 3x equal to 0. So now we put them in the equation form like this, which is equal to what? 0. So if they are equal to 0, then our first representation is what? Minus y, and we take the coefficient. So the coefficient here is 1, coefficient here is 1. So we take them as what? 1, 1. Alright. And our second one, if you want to represent it, this one will have to cross the equal sign. So it becomes what? Minus y prime minus 2c1 e minus 2x plus what? 3c2 e 3x, which is equal to what? 0. And that one, when we want to write, becomes minus y prime, coefficient minus 2, and the coefficient here is 3. And the last one, you can do it, but I'm writing there. This one straightforward. That will give minus y prime prime, 4, and what? And 9. So this is how you put it in the matrix, and you find what? You put it in the matrix, and you find your, what do you call, your general equation. You can generate your general equation. So the whole of this was like C1, 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 and here's what? C2, C2, C3. But we'll be dealing only with the coefficient, so it doesn't matter. But if you are generating and want to put it there, you can just put it there. And here's C2, C2, C2. But we're dealing only with what? The, what do you call, the coefficient. So now, when you take it here, you can take it as plus 1, minus 1, plus 1. So therefore, to take the first one, plus 1, that was what? Minus y. Multiplying. So when you cross that away, you get what? Minus 2, you get 3, you get here as 4, and you get here as what? As 9. So we come to the next one, which is our plus, which is minus 1. Are you getting it? So it's minus 1, also here. When you cross that out, also you get what? Minus y prime, 3, minus y prime prime, and what? Our 9. And the last one here is also plus 1. So when you cross that one also out, you are getting what? Minus y prime, minus 2, minus y prime prime, and 4. Alright. So this is the matrix alternative you are doing. So now you find the determinant. So you get minus y into bracket, minus 2 times 9, which is minus 18, minus 4, 3, which is what? 12. Alright. So now we have this. And the next one is minus 1 into bracket, minus y prime times this will be what? 9. Sorry, we give you minus 9y prime, minus into bracket, minus this times this will be what? Plus 3y prime prime. Plus 3y prime prime. And the last one is plus 1, which gives you minus y prime and 4 will be what? Minus 4y prime. Minus minus will give you positive 2y prime prime. Positive 2y prime prime minus. So it will be a minus 2y prime prime. Alright. Alright, so with that being said, then we can simply equate this. So minus 18 minus that will give you minus 30 times minus y will be what? 30y And when you do this one, you are getting plus 9y prime. You are getting plus 9y prime plus 9y prime minus 3y prime prime. So that one also give you minus 3y prime prime. And the last one is also giving you, going to give you minus 4y prime. And this one also give you minus 2y prime prime. Alright, minus 2y prime prime. So now if you want to rearrange it very well, you get minus 5y prime prime, this and this. And we get plus 5y prime, and you're having plus 30 plus 5y prime, and you have plus 30, sorry, plus 30y, plus 30y. So now what happens here is that if you want to solve this, you divide both sides by what? Our 5, and our 5. And when we do that by dividing both sides by our 5, what do we get over here? We get our y prime prime minus that plus our 5y prime. Alright, so this one here, because it was positive, we'll maintain it as a positive. Okay, sure. So it will give us our minus 30. So this will give us minus 30, sorry. So which will give us our minus 30y. Sorry, so that will give you our minus 6y. Alright. So now if you want to change the whole thing, hey, 5 divided by 5, that's our plus y. If you want to change the whole thing, you get what? Our y prime prime minus y prime plus our 6y is then equal to what? Is then equal to 0. Will then be equal to what? 0. Alright. So now this will be the general equation. So you realize that after we are done solving, we had the same what? Expression over here. The same expression over here. And this is the general solution. I'd like you to get more questions so that you have a good understanding of what you just done.